Okay, so we're going to do applications of the sine law. So example 1, a chandelier is suspended from the ceiling by 2 chains. So it's some light fixture here, it's a light bulb. Okay, so it's suspended by 2 chains. One chain is 46 centimeters long, doesn't matter which one, and forms an angle of 60 degrees with the ceiling. Okay, the other chain is 64 centimeters long. Okay, what angle does the longer chain make with the ceiling? So what we're actually looking for right here is, let's just call it X, okay? So let's redraw this just as a triangle. Okay, let's name it A, B, and C just for simplicity. We got 64, we have 46, we have 60, and let's just name this angle A. Okay, so we need to find angle A. We have one matchup. It is angle 60, which is angle B, and the side 64, which is side B. So let's go ahead and we're solving for sine A. We're solving for the angle A. Let's put the angle on top. Sine A over A equals sine B over B. Now, we don't know A, that's what we're solving for, but the length of A is 46, and angle B is 60, and the length of B is 64. So let's go ahead and cross multiply. So we have sine A equals 46 sine 60 over 64. Okay, and I leave this entire thing in my calculator. I'm going to put 46 sine 60 divided by 64. Okay, I leave this entire thing in my calculator. I usually don't even write it down, but I'll write down this step for us. So we have sine A equals 0.622455759. And what we're going to do is we're going to get the sine out of there. We need A all by itself. So we're going to sine inverse both sides. Sine inverse and sine cancel, and then sine inverse the other side. And what we get is A equals, let's round 38 degrees. So we can simply say, let's go with purple, okay? Therefore, the longer chain makes an angle of 38 degrees with the ceiling. Okay. All right, example 2. Two angles of a triangle are 30 and 65. So let's go like this. Two angles are 30 and 65. Doesn't tell us which ones. Let's just name it A, B, C. Okay, the longest side is 34. How long is the shortest side? Okay, so let's think about this. 30 and 65, I can't label 34 yet as the longest side because I need to know what side is the longest. Let's do 180 minus 30 minus 65. And let's solve all of the angles so that we know for certainty the longest side. So this angle is 85. A is 85. And we could put proper math form, angle A equals. Okay, now, the longest side is 34. So what we're doing is we're looking for the largest angle. The largest angle is indeed 85. So opposite 85 is going to be the longest side, 34. Our question asks us, how long is the shortest side? So B. We want to solve for B. We have the matchup of A. We're solving for the side length. So let's go A over sine A and B over sine B. The pen never picks up the sign. Okay, now A is 34 over sine 85. And B we don't know, but it's over sine of 30. And all we have to do is cross multiply this up. we get 34 sine 30 over sine 85. Okay, and that equals B. This one's easy. We can just put into our calculator 34 sine 30 divided by sine 85. I get 29.557. Let's just round it to 30. Okay, B equals 30. Now, is this reasonable? And let's call this 30 centimeters. Is 30 centimeters reasonable? Well, 34 is opposite 85, 30 opposite 30. If we don't know and we're not confident, what we can do is we can simply plug this in and see if it's the same ratio. So when I divide 34 divided by sine 85, I get 34.12. Okay, now let's divide 30 divided by sine 30. Okay, I did not get that. I got 60. Therefore, something's wrong. Maybe I made a calculation error. So, this does not equal this. Therefore, they don't have the same ratio. So, let's actually just simply recalculate this. Maybe it's just an error. So, I get 34 sine 30 divided by sine 85. Oh, I get 17. All right, 17, we can call this units. Now, if I sub the 17 back in here, let's go 17 divided by sine 30. I get 34 as well. So this time, I know that I'm correct. All right, example 3. We have a diagram this time. 2 hotels are located on the same side of the river. So we have Hotel 1 over here and Hotel 2 over here. The hotels are on the bank of the river and are 400 meters apart. Across the river is the dock for the 2 ferries to bring tourists to the hotels. So here's a dock, and maybe the ferry goes back and forth to Hotel 1 and back and forth to Hotel 2. But the dock right here is not directly in the middle, but it's somewhere between Hotel 1 and 2. So the angles made by the riverbank, so the riverbank and the lines drawn from the hotels to the dock are shown. We have 36 and we have 59 here. How far is each hotel from the dock? So let's call this side H1 and side H. Oh, this would be H1 and this would be, H2. There we go. So these 2 sides we're trying to solve for. Okay, here's the problem. We don't have a matchup yet. So let's try to do 180 minus 36 minus 59, and we're going to get angle D, like the dock angle. I get 85. So angle D is going to equal 85 degrees. So let's label that. Okay, now we have a matchup, and now we can solve for H1 and H2. So because we're solving for the sides, let's go ahead and put the side lengths on the top. So we're going to go D over sine D equals H1 over sine H1, capital H though, equals H2 over sine, capital H2. And now let's just sub it. 400 over sine 85 equals H1 over sine 36 equals H2 over sine 59. Okay, so the ratio that we have completely filled in is this one right here. Okay, so what we're going to do is we're going to equate the 400 over sine 85 to the first ratio and solve for H1. And then we're going to equate it to the second, unknown, H2 over sine 59. should be extended. And then we're going to solve for the H2. So let's see. I'm going to do the first one. So the H1, I'm going to do this in purple. 400 over sine 85 equals H1 over sine 36. Okay, all we want to do is cross multiply. We have 400 sine 36 over sine 85. And what we want to do is just punch it into our calculator. 400 sine 36 divided by sine 85. We get 236. So 236 meters. Okay. Now let's go red. 400 over sine 85. See how we're using the original again? So we're actually given the information about 400 and sine 85. So I would use that. Like I wouldn't go ahead and use 236 because we solved for the 236. So we just want to make sure that we're correct. And if we made a calculation error on H1, then we're definitely going to make that, like we're going to carry that error over, right? All right, sorry. This is H2 this time, sine 59. Okay, so the original, which is 400 over sine 85, and we're equating that to H2 over sine 59. All we do is cross multiply. So 400 sine 59. And then we're going to divide by sine of 85. And we're going to solve H2. So 400 sine 59 divided by sine 85. I get 344. 344, and that's measured in meters. And all we have to do is write a therefore statement. So we can write, therefore, Hotel 1 is 236 meters away, and Hotel 2 is 344 meters away from the dock. All right, last question. Example 4, 2 tracking stations are 20 kilometers apart. So let's actually label that right here, 20. And that's just from one tracking station to the other. The angle of elevation of a rocket that was launched by a weather satellite from Station A the angle of elevation is 41 degrees. Okay, so that one's already in it. From Station B, the angle 875 degrees. So the angle of elevation again. What is the altitude of the rocket to the nearest tenth of a kilometer? Okay, so the rocket, it asks for altitude. So we know altitude meets at 90 degrees. Okay, so let's use sine law to solve for this. Okay, so I'm just going to label this. I'm going to label the altitude H for like height. And I'm going to label from the tracking station B to the base right here, X. So let's use sine 41 over H okay, so sine 41 over H. And then this big triangle, if we actually look at the big triangle, we have 41, and then we have a right angle triangle. So all we'd have to do is 180 minus the 41, and we get 180 minus 41, sorry, minus 90, and we get 49. So 180 minus 41 minus 90, and we get 49. Okay, so this entire angle right here is 49. So sine 41 over H equals sine 49 And let's call this is 20. This entire thing right here is 20 plus x. Okay, so let's put this over 20 plus x. Okay, let's actually flip this. So we have h over sine 41, and we have 20 plus x over sine 49. Okay, so remember, this is the exact same formula. Okay, in this formula, we did the angles on top, but we want to solve for h, so I just flipped it and put the sides on the top. And now if we cross multiply, we have h equals 20 plus x sine 41 over sine 49. Okay, now let's do a second equation for the smaller triangle right here. And let's just stick to sine law. Even though we could use SOHCAHTOA, I'm going to show you something with this. Okay, so let's go h over sine 75 equals, and then we're going to solve this angle right here. So it's 180 minus 90 minus 75, and I get 15. Okay, so equals x over sine 15. Cross multiply that up, h equals x sine 75 over sine 15. We've seen this before. We have two equations, two unknowns. Yes, we have to do substitution or elimination. So let me switch to the next page. Okay, so here we go. We have these two equations. Let's actually just equate them. So we have x sine 75 over sine 15. And we're going to equate that to 20 minus x sine 41 over sine 49. Now, let's distribute this in. So we'll leave x sine 75 over sine 15. And we get 20 sine 41 minus x sine 41. Okay, so both of these are over sine 49. So let's just put them individually. So sine 49, and this one's going to be over sine 49. So now all we have to do is actually collect like terms. So we have an x sine 41 over 49 over here, but simply we have an x. So let's bring that over. So now what we have, and let's actually just solve this so it's easier. So if we do sine 75 divided by sine 15, let's round it to like 3 decimals. What I get here is I get 3.732x. Now, sine 41 over sine 49, I get 0.869. Okay, so bring this over and it's plus 0.869x, and that's going to equal, and let's solve this. We have 20 sine 41 divided by sine 49. I get 17.386. Okay, add these two together. .732 plus 0.869. I get 4.601. So we have 4.601x, and then we want to divide both sides by that number. So those cancel, 4.601, and we get x equals, x being the height, no, x being the base, x equals 17.386 divided by 4.601. I get 3.779. So this right here is the x value, which was just of the base of the right angle triangle. So we can take that x and we can sub it into either one of these top equations. I'm going to choose equation 1 because it doesn't have that bracket in it, and we can solve for the height of our paper. Let's go. H equals 3.779 sine 75 over sine 15. Okay, so 3.779 sine 75 divided by sine 15, I get 14.1. So let's just say the height is 14, I believe it's meters. Therefore, the height of the rocket is 14 meters.